And today, we will be learning about parallel lines and proportional parts. Oh, yeah, and speaking of which, this is one of my late live streams, so I think it's 3:17 right now because I wasn't able to do it this morning because I was real busy doing stuff. So now I'll be able to do 7-4 of my students. I don't think I have class right now. Technically, this is 7th period for my students. I'm just doing my normal first period talk with my students for my algebra 1 class tomorrow. I'll be doing another live stream at 4:30, I think. 4:30. Depending on how long my live stream gets today. Okay? Yes, and as you all see, I got a haircut on Tuesday night, I think. Either Tuesday or Wednesday night. Okay. So, just as a reminder of what we're going to be doing today, we are going to be doing the Geometry Lesson 7 for parallel lines and proportional parts. So, if you have any questions, comment down below. And if you're confused, type it down in the comments. Make sure you leave a like and subscribe. Okay? Let's go for it. And I just gained 1 like. Okay, thank you for liking. Make sure everybody subscribe. So, I'll remove my fan here. This is live number 14 of my mathematics series. Wait. I have playlists for every single one of my classes. So, okay. So, if you have any questions, comment down below. I will make sure I'll answer every single one of your comments, okay? And I already have 16 views of 2 likes. Let's get going. Okay, so, speaking of which, this geometry lesson. Okay, so if you have a geometry teacher at your school, while I'm on, where at Monoi, Brazil. What the? Yeah, I could tell that's the Brazilian flag with green. Oh no. Okay. Yeah, no flags. There's a Brazil, 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 and then the other one says Brazil 9 times. Which is Brazil to the 9th power. Okay, let's get going. So, I do not want to keep you all distracted. You cat's eye? No! No. I'm not cat's eye. Wait. Yeah, I do not know if this is Brazilian or not. So, let's get going. So, it's only Manawi. Okay. Pale pink. Just as a normal reminder, I like wearing pink on Fridays, okay? Every time that I wear pink, it is a Friday. So, I got pink and black and purple, I think. my shirt because I kind of like wearing pink. Okay, let's do up. Okay. Okay, let's get going. I'm gonna get my things ready to take notes. Here's the purple. And I think I need red, blue. Okay. Oh yeah, I'm at 252 subscribers. Okay. This is like so crazy. Oh shoot, I need orange. Yeah, I don't even remember where I was coming from. The vocabulary, body, to the sea line dance. No! Yeah, I'm here to teach geometry, not to do a sea lion. But speaking of which, okay. So here's what we're going to be doing. Triangle. Proportion. Ality. Theorem. New sub. How old are you? I don't not normally show my age, okay? Will you remember me in 5 years? 2031. I don't know. Because all I know is that in 5 years will be 2031. Which in that case, I'll be an adult by then. And speaking of which, okay. Yeah, no jokes, no 6-7s, okay? Okay. Okay, so I'm kind of getting myself distracted. So if I'm getting you guys distracted, so let's see. 4, 2, 2, 2. I'm fine with numbers like 4, 2, 2, 2. Okay, so if a line parallel to one side of a triangle plus for my 10 years. What 10 years? Triangle plus intersect, triangle and intersect the upper two then it divides the sides into segments. Of proportional lengths. I think that's okay. So here is an example of triangle proportionality theorem. Okay, so I'm a male. I like wearing pink on Fridays. Don't judge me. Thank you. So, example. If segment BE is parallel to CD, then MAB, segment AB, divided by MBC is equal to MAE divided by ED, sorry. MED. Oh, we have a new person. Fan HDU5. Okay. Hi. I do not live in the UK. Sorry. I'm from the United States. Thank you very much. I kind of look like I'm Canadian, but I'm not Canadian. I'm born in the... Yeah, I'm American, United States. So, okay. So let's see. We have this triangle here. I'm gonna split the line. Let's split the triangle. Does one of these look like a trapezoid? If so, comment down below if it's the left side or the right side. Did you have any diabilities? You mean disabilities? Well, I honestly don't know that one, but I don't think I have a disability. So, they keep asking, but I don't have a disability. So here is point A. This is point B, point C, point D, point E. Okay, so let's just say this one is 11 inches. This one's 11 inches. This is 6 inches. 6 inches. Okay. So AB is 11 inches. Divided by BC, which is 6. So 11 over 6 is equal to A over E, 11 inches, over E over D, 6 inches. So 11 over 6 equals 11 over 6. What did I do? I just asked, do you have a disability? Yeah, I don't have a disability. Yeah, I don't have a disability. Sorry. Yeah, I just don't have a disability. Okay. Okay, I think that's the only vocabulary word I know of as of right now. Is that advocate who told me, yeah, you should not be having arguments in chats. So, yeah, you should not be doing arguments, okay? Okay. So, I'm ready to give you an example. Using the triangle proportionality theorem. Okay. Oh, I know. Wait, what? It's me, Zach Arts. Okay. Now I think I know some of you. I apologize. I didn't have a comment. So, if anyone is in geometry, put a comment down below so that I know. Thank you. So, for example, okay, so let's see. In triangle PQR, segment ST is parallel to RQ. If PT is equal to 7.5 TQ is equal to 3 and MSR is equal to 2.5. Find PS. Huh? Body now. Sorry. Okay, so speaking of what's behind me, there's nothing scary behind me. Oh boy. Oh boy. Okay, so we're gonna show our work. Wait. So we know all of this, right? So we know about these measures right here. So, speaking of which, we have to identify what this angle is. This thing is. So, let's do MPS divided by 2.5 is equal to 7.5 divided by 3. Well, in that case, you kind of have to multiply one of those by 3. Huh? Oh, no. No new comments. So, let's do 3 MPS divided by 3 is equal to 18.75 divided by 3. Then MPS is equal to 6.25. And you know what the thing donated 6,000. Okay. This is like so crazy. Yeah, so here's the triangle. Well, I'm gonna divide this here. So this is S, T, P, Q, R. It doesn't truly matter what letter you use. Okay? It doesn't truly matter. So this is 2.5. This is 3. This is X. And this is 7.5. Okay. Okay. So. Okay. So if we figure out if 6.25 is actually x. Would that be our unknown? It should. So, okay. Here's another term. Okay, so now we're going to deal with the converse of this term that I taught you. So with this term, it's the converse of a triangle proportionality theorem. So instead of me just writing it out, I'm just going to tell you what it is. So, the converse of triangle proportionality theorem. Now, if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then a line is parallel to the third side of a triangle. Just going to stretch it out. Okay. Log. So, speaking of which, C, D, B, E, A. I think. Okay. So if segment AE is equal to CD, then the segment A, the line A to C, the points A to C, will be parallel to the line of set points E and D. Okay? And speaking of which, if you're, well, the points of B and E are the same exact distance between points B and D. Okay? So, let's see. Okay. So we're going to find an example of that. Well, maybe not. Okay. So here, something's, yeah. So, okay. So let's see. So we have a triangle. If we have a big triangle connected, I'm going to erase this triangle here and show you an example. So this triangle, okay, I'm going to do like this, here. We all call this a triangle, right? So what if we do other triangles? Okay, so one point touching here. We have two, well, we have one triangle still. Because we have a triangle and a trapezoid. And then we have another line touching from here to here. We have two triangles now. One of them is a rhombus. So, Haystack arts. Okay. And then we have another line connected from here all the way down to here. We got four triangles. So how on earth can we possibly get four triangles from one big triangle? well, we have one triangle inside of this triangle. And so now we have 1, 2, 3, 4. 4 triangles. This is what geometry people call mid-segments of a triangle. And you know what that is? Well, it's a segment with endpoints that are the midpoints of 2 sides of a triangle. How are you? I'm doing good, Zach. Thank you. Oh, yeah. So, speaking of which, we have another triangle thing. Okay. But this time, we're going to be dealing with what? Right triangles. Okay. You know triangles of 90-degree angles? Okay. So, now we have here, then here, oh, here, we have 90-degree angle. Okay. So, well, let's see if we could do here. Well, now what is that called? Triangle mid-seg point theorem. So, this is points K, G, H, J, F. So, a triangle mid-seg point theorem is a mid-seg point of a triangle. It is parallel to one side of a triangle, plus, and its length is 1/2 the breadth of that side. Like, geometry is wording about triangles and 3D shapes and 2D shapes. So including area, perimeter, everything else. So, speaking of which, we're almost 28 minutes, or we're nearly 28 minutes through the thing. Okay, so now we have an example. Other than those 2 vocabulary terms that I didn't even write out because I could just teach without me writing down the whole entire word, its whole entire definition. Okay, so this one has 2 acute angles and 1 obtuse angles. So, here, here. And apparently, people call this the obtuse. It's 124 degrees. Okay. Well, that kind of looks like it. Right. So that's much better. So now I have 13. Okay, so in the figure, the lines between points X and Y and X and Z are mid segments of triangle RST. Find X, Y and XZ, Y and ST, plus angle R by X. So speaking of which, well, we need to find the length of that angle right there. So So here, okay. So, okay, so XZ is technically the same thing. So you just have to divide 13 by 2, which we get 6.5. So speaking of which, why do we get 6.5 from dividing 13 by 2? Well, that's true. So, want to do yearbook? Let's do yearbook R. Wait, what? If I say RN? Yeah, so how are you? Want to do yearbook? Let's do yearbook RN. Okay. Okay. So, MST. Sorry if I cracked my voice. So, this apparently says that it's at 17. It kind of looks like a 77. Nope. Yes or no? Okay. Well, sure. Let's go for it. So, speaking of which, well, let's test to see if this is. Oh, I don't think that's 180 degrees. So that's where my handy dandy protractor comes in hand. So 150. So 150. So we're going to subtract 150 minus 124. We got 26. So this side must be 26. This side must be 26. This will be 124. Wait, this is not true. So this will be 56 because supplementary angles have to add up to 180 degrees. So why are we doing this if we don't even know that it equals 180? Well, that's when I check work. So how I check work is that I would subtract 180 by, no, sorry, by 124. Well, wait, yeah, oh, here. Okay, so 80 minus 24 is 56. 110. So that would be 56. So, according to my trusty protractor, from here all the way here is 150 degrees. So 24 plus 26 is 150. Okay. So, speaking of which, I have quite a couple of terms. Proportional parts of parallel lines. So, if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So, this. Okay. So, here is something that I keep in mind. So, if, yeah, sometimes I do geometry and math. So, and speaking of which, I teach geometry, first period. Huh. Okay, 2 people, okay. So, apparently, it's 3 straight lines. Can you see those 3 lines? So if you do, comment yes. If you don't, comment no. So, oops. I picked that one too far. That. Here and here. Well, apparently this is A, B, C. And it says E, F, G. Okay. And apparently, this is geometry. Geometry has algebra. Lots of it. So, that's where kind of I come into hand. So, for those of you who are still watching, continue to watch. Thanks for liking and subscribing. So, angles A, B, and C equal to angles D on E, F, G. Or it's called CBA or GFE. I know. Okay. So, I think we have one more turn. And then congruent parts of parallel lines. So let's see how we managed to get through this. So if three or more if three or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every single transversal. Okay? Every single transversal. So, speaking of which, let's test this out. Okay. Huh? Oh my god. Please go fix them in the comments. Thank you. So, let's see. Okay, let's see. Well, if it cuts off like this, well then, if it goes like this, then I'm guessing we're okay. So, we have finally one more example before we're going to be done with the whole entire lesson, okay? Okay, 7 likes. Okay, thank you. So I'm a math mastermind, particularly. So, even though I still go to school, which I should be, I never miss a day. Oh, that occurs rarely if I ever miss a day. So, find X and Y. So this is what I call algebra. So here is what it says. So, J, K, L, B, M, P, Q. Okay. It says, for this one, 6x minus 5. And then it says 4x plus 3. And then on the bottom, it says 3y plus 8. And then the other one, 5y minus 7. But we must find x, and we must find y. So why are we finding x and y? Because x and y are the most common variables in algebra. Okay. So I'm just going to tell you this because I have to check on something. Okay. So x is going to be 5, y is going to be 7.5. Okay? So thanks for watching. Like and subscribe. Bye.